Hey guys, welcome back to another week of robotics. This week what I want to do is I want to talk a little bit about buttons, and then also we're going to do a little bit more work with moving around on the DC motors. So the reason I want to talk about the button is because as we get to the part of our project here where our robot starts moving around, we want to make sure that when we give the robot power, it doesn't just start driving right away. It's kind of like if you're going into a car, once you turn the car on, you don't want the car to be moving right away, right? You want it to be stationary, like parked, and then when you press the gas pedal, it starts moving. So same concept with our robot car. So the idea is that the button is going to control all the moves of that. Once you get the power, it's just going to chill there, just wait for you, and then once you press the button, that is when the robot car starts moving. Okay, so let's learn how to do that. The first thing we want to do is talk a little bit about buttons. This might be some review for some of you guys out there, and for some people it might be new. So I'll go over it just so that we can all cover it. So if it's a review, it's a good refresher. If it's brand new, it's going to be a good lesson as well. All right, so let's talk about the button. All right, just writing it out here. Okay, now what does the button look like? We need to go grab it from the kit. It looks like this. You can see in the top right there. It is a, let's make sure I get there. Yeah, it's got 4 legs. Okay, and so let's go ahead and draw that. Okay, 4 legs. And the first thing I'd like to say about the button is that the button can go 2 ways in terms of orientation. Okay, so what I mean by that is when you're looking at it, okay, you can turn it this way, which is where the legs are going from side to side, or you can turn it this way where the legs are up and down. Okay, and I'll draw it in this picture here on the whiteboard to make it more clear. So here is side to side, the legs are side to side. You could also turn it this way where the legs are on the top and the bottom. Okay, and my rule here is as we're working with it and putting it on the breadboard, do not turn it this way, okay? Because if you turn it that way, everything's gets messed up. All right, so let's just do that first thing. Let's go ahead and take this and let's put it on the breadboard. So this is my breadboard here. Yours might be a different color. All right, and let's go ahead and put it somewhere where the legs, you see that there's a valley right here, okay? Let's go ahead and put it on like that, and make sure that two of the legs on the left go on one side of the valley, and 2 on the right go on the other side of the valley. So the button should be kind of bridging the valley there. All right, and just a quick review on the breadboard, how this thing works. A bunch of holes here on the left side, bunch of holes on the right side. Okay, so I like to call these 2 different sides of the valley. This is valley side 1 and valley side 2. And the rule is this, okay? So you see all these holes on this row right here? If the holes are on the same row and on the same side of the valley, those holes are connected. All right? So I'll just leave it at that. You can kind of think about that. If you have questions, we can talk more later, okay? So if the holes are on the same row and also on the same side of the valley, those holes are connected. All right, and we'll do some examples and make more sense if that sounded confusing. All right, so we have our button there. Good. And let's talk about the button, how this thing works. So this is called a 4-leg push button because there are 4 legs, and here's how the legs are connected. So the top legs, I'm drawing a line here, are actually connected together electrically. So if I put some kind of electricity or voltage here, the same voltage will go here and travel all the way to this side on the right. Okay, so it's connected by a wire. And then the bottom two legs are also connected. All right. Now how about the top and the bottom? The top and the bottom, they are not connected together electrically. Okay, so there's no path between the top and the bottom. But when you press the button, so I guess I'll color it in. When you press the button, what happens is that the top, I'm putting a dash line, the top connects to the bottom. Another way to think about it, when you press the button, all four legs are all of a sudden connected electrically. Okay, and so that's how the button works. When you don't press it, you don't have the connection between top and bottom. But when you do press it, you do get a connection. And so we're going to use that fact to trigger motion on our robot. Okay, so let's take a look at our breadboard here. And let's see, well, we've got our button is there, and we've got the four legs connected, and let's do some thought exercises here. Okay, so I have this pin-to-pin wire here. It doesn't really matter. I just got a orange one. Yours can be a different color. All right, and I'm gonna switch screens here. Okay. So based on what I said about the button and the breadboard, I'm gonna take one pin here and stick it right here on row number 2. Okay, so row number 2 is going to be the same row as the top leg of the button. So once I do that, this orange wire is now connected to the top row of the button because it's on the same row. Now, question for you. Thought experiment, okay? This red wire, different wire, I'm going to put over on this side, which is row number 2. Question. Is the orange wire connected to the red wire? Think about it. It's kind of a trick question. So the red wire and the orange wire, they're on different sides of the valley, right? So remember what I said, the holes are only connected if it's on the same row and it's on the same side of the valley. So because the red and the orange are on different sides of the valley, you might think, well, the red is not connected to the orange then, right? Well, that's correct in that thought, but we also have this button here. And what does this button do? Well, the button, if you remember, if you look on the top right corner with the lines I drew there, for the button, the top two legs of the button are actually always connected. So what's happening is the button is acting like a bridge, is connecting the right side of the valley on row 2 to the left side of the valley on row 2 because of that bridge on those two top legs. So because of that, the orange wire is actually connected to the red wire. Okay? Now, what if I move the red wire down here to row 4? And row 4 is connected to the bottom leg of the button. So question now is, right now as we look at it, is the red wire connected to the orange wire? The answer is no, because they are on different rows, right? They're on different rows, so it's probably not connected. But then we also have to look, well, what else is connected to those rows? The other thing that's connected to these rows is this button. And now, if we look at the picture on the top right, we see that the top wire, or the top two legs of the button, they are not connected to the bottom two legs of the button, right? The only time that they're connected is when I press the button, and when you press it, you hear a little click. When you press it, now the top two legs of the button, they are connected to the bottom two legs of the button, and because of that, we're going to have connection between the orange and the red. Okay, there we go. All right, so that's a little thought exercise about the button. If you have more questions about that, we can talk about that. But that's just a little exercise to kind of get our brain going, thinking, figuring out how this button and the breadboard works together. Okay, so now that we have that, let's figure out how to connect this to the Arduino. All right, so I have my Arduino over here. Let's go to the whiteboard and figure out how we're gonna connect this thing. Okay, let's make some room here. Okay, so we're gonna have our Uno. And we're gonna have our 4-pin button. And this is what we're gonna do, okay? We're gonna look at pin number 2. We're gonna connect pin number 2 to the top leg of the button. And remember, the top leg is also connected to this. Okay, what I mean is the left top leg is also connected to the right top leg because the two top legs are connected already, right? So pin 2 is now connected to both top legs of the button. And then what we want to do is take the bottom legs, and remember the bottom 2 legs are connected. We're going to connect the bottom 2 to G and D, like that. Okay. And that's it. That's it. That's all we got to do. All right. So let's think about this. So what's going on? Remember the button, right? How it works. So what's going to happen is that when we press, so let's write this out. When we press the button, what's going to happen? When we press the button, 2 is going to be able to connect all the way to G and D. Okay? Because remember, when we press the button, there's a path between the top and the bottom. So let me erase that. Okay, when we press the button, 2 connects to G and D. Okay, but when we don't press, what happens? When we don't press, 2 is not connected to G and D, because what happens is 2 can go like this, but look, there's no path to G and D. Okay? So when we don't press, 2 is not connected to G and D. All right? Now, this will kind of come into context. It will make sense when we start coding, and so I want to give you a little like hint right now. All right? If you remember, early on we talked about G and D. Might not have been this series, but the previous series. G and D is the same as minus or low. Okay. I'll put an L. Okay. Minus or low, G and D. All right. And then we have the other side of that. We have VCC or power, or 5V. Okay. That is the same as plus or high. Okay, G and D is minus or low, and the 5V or the main power is the same thing as plus or high. All right, when we're talking about electronics in the Arduino. So what that means, okay, trying to take that together. Okay, so when I press the button, 2 is connected to G and D, which is the same thing as minus or low, right? Let me make sure we can see here. And then when we don't press, what does it mean? When we don't press, 2 is not connected to GND. So where is 2 connected to? Well, actually, what's going to happen is that 2 magically inside the Uno is going to be connected to the 5V with the squiggly line, a resistor. Okay? So when we don't press, 2 doesn't connect to GND. It's actually going to connect to 5V inside there. So it's going to be a plus or an H. Now this little resist or high. This little resistor you can't see. It's actually inside the Arduino Uno. And it kind of like magically does its job of connecting it to the plus or the high when you don't press the button. And that is called, I'll just go ahead and write it out, a pull up resistor. Because it pulls up the voltage to the high. So pull up, like imagine you're doing pull-ups, like exercise, right? You pull up, going high. Okay, that makes sense. And then this will totally match with the code when we get to coding. All right. So let's change our view here, and let's do this. All right. So I have orange here. You know what? I'm gonna go ahead and change around my colors because I like to use, and we always, as a convention, we want to use power as red and brown or black for the GND. So let's do the bottom row. So the bottom row of the button, right? I'm gonna connect. I got brown here, which is, yeah, either brown or black. Let's put it in there. Let's connect this other side to GND on the Uno. This one, and there's several of them, so that should be good. Okay. All right, and then the next thing is I'm gonna get orange now, and let's connect to the top row of the button. And following my wiring diagram on the top left, where does that go? That goes to pin number 2, right? So let's find number 2. Pin number 2. There. And that is it. That's a pretty simple wiring exercise, right? Okay. Make sure we can see here. So it looks like this. Okay, and I'm going to move these to the side. You can kind of see it better. Just like that, okay? All right. Now, let's do some coding. All right, so I have my setup here. These are my 2 DC motors going to the DC drive. Those are all connected in, and then I have my button here. So this is my code from last time, and if you remember, we had motor B is controlled by 10 and 12, and motor A is controlled by 8 and 11. So if you need help on that, you can look at the previous video, but I already have this set up, so I'm not gonna go all into that right now because we want to work on the button. All right, so then now let's look at what I have in my code here. In my code, I have motor B is off because high and high on both 10 and 12 is off, and then motor A, the control signals 8 and 11 are also high and high, so that's why it's both off. If you remember, if the control pins for the motor are both high or both low, it's off. All right, so imagine if this is low and that's low, and if this is low and that's low, they're both off. All right, and just to make sure that I'm not lying to you guys, let's upload, and it should remain not moving. Cool. Okay, that's cool. Now let's add in this button code. So we need to set up the pin mode. So this will be called button setup. Pin mode. Now which pin did we connect the top row of the button to? It was pin number 2. And we're gonna do comma input. Okay? So this is an input because the button is actually it's a very simple sensor. So when you press the button, the robot can feel, it's like a sense, and it's the touch sense. So that's why the senses always go in. So that's why when the button is a sensor, which is an input into the Uno. Now, remember earlier I was talking about this resistor thing? Okay, going back to this, remember I said that there's this internal pull-up resistor that allows pin 2 to connect to high whenever you don't press the button. So how does that come up? Check this out. So it's not just input. We want the magical pull-up resistor inside. So we want to say input underscore pull-up. When we say that, we tell the Arduino Uno to use the magical pull-up resistor inside there so that when I don't press the button, 2 becomes high. If I don't do that, it's not going to work correctly. So we want to make sure we put input pull-up to use that magical pull-up resistor on the inside of the Uno. All right, so if we do that, our button is set up. Let's just make sure that all is good. Let's just upload this. It's not going to do anything. We just want to make sure I don't have any errors in my code right now. Okay, cool. All right, so now that we have that, let's go ahead and do something here. Let's say we're going to use a conditional now, okay? Because it's going to say if I press the button, do something. If I don't press the button, do something else. Okay? So I'm going to write a comment because it helps us keep kind of organized here. So if I press the button, let's say move motor A. Yeah. If I don't press the button, stop motor A. Okay, I think I have this. Check it out. So if I press the button, then we do this. Digital read to, hold on. This is confusing because of all these parentheses, so let's do this. Okay, so digital read to, this returns, this allows you to read the value of pin 2. So remember, if I press the button, what happens to pin 2? Is it low or high? Go back here. Remember, when I press the button, 2 becomes G and D, which is low. Okay? So when I press the button, that means that it's low. All right? And then what do I want to do? I'll put my braces here. All right. So whatever you want it to do, you put it in between these two braces. I want to move motor A. So I do digital write A8 low and digital write, what's the other control pin for motor A? It's 11. I can see it on up there. High. Remember, to make it move, you just have to set one low and the other one high. So, all right, let's review this. So, digital to read equals low. That's just the computer's way, the code way of saying if I press the button. Okay, if this is true, so if pin 2 is true, it means that the button is pressed. Now, if I don't press the button, so I can say if, actually let's write it down here underneath the comment. If I don't press the button, that means digital read to, if I don't press it, it's actually high because of my special pull-up resistor. Then I want to A comma high. Let's set them both high. Cool. So if I don't press the button, which is the same as digital to read equal high, then I want to turn both high, which will make motor A stop. Now this stuff I don't want anymore because I don't want this to run. I only want my button code to run, so I'm going to comment this guy out. All right, let's go for this. Hopefully it works. If I press the button, motor A should move. And motor A, let's see. Motor A is this one. All right, this one, where my finger's tapping. All right, pressing the button, go. It works. Press, let go. Press. All right, so my code is working. Excellent. So now what I'm gonna do is assign some challenges, and you guys go from there. All right. So the first challenge is to do what I do. That's always the simplest thing, is to wire the button and get motor A to move when you press and stop when you don't press. Okay. Then the second one, once after you get that to work, why don't you try to do the same thing, get motor B to move when you press and stop when you don't press. So same thing that we did with motor A, except do it to motor B. That should be pretty easy, right? We just need to change the control pins. All right, challenge number 3. Get both motor A and B to move when you press, and both to stop when you don't press. So when you press the button, both should go. When you let go, both should not go. Okay. Number 4. All right. When you press, move both move both motors forward for 1 second and then stop. Okay, so how that works is like when you first upload the code, nothing happens. When you press the button, both should move forward for 1 second and then stop. So if you have this connected to your car, what's going to happen is you press it, your car will actually move forward for a second, stop, and then just chill out. Okay. Number 5, when you press, move both motors backward for 1 second and then stop. All right, so the opposite of number 4. And then number 6 would be this. Do tape challenge. What does that mean? I'll just kind of verbally tell you guys. Or you know what? Let me write it. What is the tape challenge? So once you kind of figure that out, the tape challenge is this. Okay, so let's say you have your car, your little Rover here. Okay, this is my car here. Okay, and this is the ground. All right, so somewhere you're gonna put a piece of tape down. That's my tape. Okay, so some distance. You don't know, right? So what you want to do is just put it at a random spot and then try to program it so that when you press the button, your car will go here and stop exactly at the tape. Okay? And so you want to see how many times I mean, my guess is that you're not going to get it right right away. Okay? But you can kind of have a challenge yourself. I would say, how many times do you have to change the code in order to get this? I would say a very good number. If you could, like, to get it right the very first time is, you know, really, 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 really hard. See if you can get it to work under 3 changes. Okay, so that would be like a really good number. I mean, maybe the first time you do it, it might take 10 times or 20 times. That's totally fine. But as you do the tape challenge, you're going to get better and better at figuring out, okay, how to adjust the code to get it to that point. So once you do the tape challenge once, go ahead and move the tape to a different distance and do it again, and you'll see that the number of times that it takes for you to get it just right to stop at the tape is going to get less and less. All right, so what I mean by that is that, let's say the first time you do it, it takes, I'm just going to say 30 times, because maybe it will take 30 times for you to get the car to go stop exactly at the tape. And then once you do that, you're like, great. And the idea is that you want to learn a little bit. So what did I have to change in order to get it just right? But as you learn that, that's going to help you for the second time. So the second time you do it, move the tape somewhere else, so it's not going to be here anymore, right? Let's say you move the tape here, okay? Like closer. I would say probably the second time, because of what you learned about the coding and stuff, because of what you learned, maybe it's going to take 20 times instead this time. All right. And then the third time you try, you move the tape again, and maybe it takes 10 times. And then the fourth time you do it, maybe it takes 5 times. That kind of thing. Now the key here is not really the number, okay? 30, 20, 10, that doesn't matter. It could be 100 to 50 to 40, okay? The goal here is that each time that you change the tape position, the goal is that it takes less and less amount of code changes to hit the mark. All right. Now the only way to do that is that you think and you kind of learn about the code and about what you need to change in order to get it to work. Okay. So the idea here is to learn a little bit each time that you do the tape challenge, and then you'll see like a pattern. All right, which is going to help you reduce the amount of times you need to try. All right, so that's what I have. Little challenge for you. This part is kind of fun. It's little investigation, which is part of robotics too. Is that sometimes you're just gonna code the thing and make the thing move, and then you observe. Well, what did it do? What did I do? And what did it do? And then try to learn from that, and you get better and better each time. So I look forward to seeing what you guys learn, and have fun. I will talk to you guys later.